All right, lecture 4.5, exponential equations. Okay, so we have this rule here. So hopefully you've seen exponential equations before, but we're going to go back into them in this class. So if you have an equation where you have one exponent equal to another, okay, and the bases are the same. Okay, this is a very important part. You need to have the bases are the same. So they're both a, for example. If they're the same, then we can assume that it must be that their exponents are also equal to each other. So you can, in a sense, just drop the bases and equate the exponents. Okay, it's a handy rule there. All right, another thing that we have is, so if we have log of a, log base a of capital A equal to log base a of capital B, then we can assume that a must equal b. So it's a similar idea here. As long as the base of your logarithms are the same, we're allowed to assume, or we can assume, that it must mean the arguments of our logarithm are therefore equal as well. Okay? And that also goes with natural logs. Same idea, the base is the same, so you equate the arguments. And then here, so if we see log base, well in this case it's base 10, of a equal to c, and we're trying to solve for what's in the argument, okay, so solving for in the argument, then we just convert it to exponential form. So if you're trying to get to your variable, which is inside the argument, you switch to exponential form. Okay? And same thing can happen with natural log. All right, so we're going to be asked to solve for example 1, and we're going to state the exact solution. Okay, so, and if we need to, we'll round to 3 decimal places. All right, so a. Well, this is exponential, so these 4, I'm not going to really look at these 4. I'm going to look at this first rule. Can I solve using that first rule? Well, at the moment, that's a base 2 and that's a base 8, so I can't do it yet. But I can be sneaky, and I can change 8 to base 2. Okay, I'm going to go ahead and do that. So 2 to the x equals, well, 8 is the same as 2 cubed. So I rewrite 8 as 2 cubed, and what do you know? Now the bases are the same. So because the bases are the same, I can in a sense drop them and equate the exponents. So x equals 3. All right, so b. Well, you know, there's really no way to make 7 look like e to some power. I don't know how to do that. So since we cannot do the first method here, my plan is I'm going to take the natural log of both sides. So why did I choose the natural log instead of the common log? Well, it's because I have that base e there. So if this was 10 to the x power, I would probably have chosen the common log. But because it's e, I'm going to choose the natural log. Okay, so let me rewrite this real quick. So I'm going to take the natural log of both sides. I'm going to grab out my pink here. So natural, ooh, darn it, that's the common log. Natural log of both sides. Okay. Take the natural log of both sides, and when we do that, this will cancel out with the base of e, and I'm left with x equals natural log of 7. Okay, we can go ahead and plug that into our calculator. Let's see. All right, so let's see natural logs. We're going to go for log. Let's see, pulling it out. Ooh, I was using the other calculator the other day, so there we go. I was using the wrong calculator yesterday, so I've forgotten where all my keys are on this one. Okay, so natural log of 7, plop that in. What do we get? 1.945, yeah, okay. So x is approximately 1.3 decimal places out, 9, 4, and we can round up 6. Okay, so in case you were wondering how I got that, as I took a while to figure out that one, there's your natural log button right there. Okay. All right, my other calculator died, so I got a new one. All right. D. Well, it's also exponential. My variable is up in the exponent. Okay, that was one thing I forgot to mention. Notice, this is all when your variable is in your exponent, okay? This is a kind of a different way of solving it. So, plan here. I could take the natural log of both sides, but what I want to do is I want to get the base that has the variable. I want to get that by itself. Okay, the base with the variable by itself. So to do that, I'll divide both sides by 5. Okay, and then I have 2 to the x power equals 7 over 5. All right, now what I'm going to do, I'm going to go ahead and stick with using the natural log or the common log. So some people would like to just take this by log base 2, and that would cancel out that bottom 2. I'm going to stick with natural log or common log since those are normally what we have on a calculator. So I'll go ahead and take the natural log. Why? Because it's shorter and easier to write. Okay, let me make space of that natural log there real quick. So as I said, the reason I'm choosing natural log over the common log is just because it takes less time to write. Okay, logging both sides, and then I can go ahead and use that exponential rule and bring the x out front. Bloop. So I have x ln of 2 equal to ln 7 over 5. Okay, and solving for x, we have it being multiplied by the ln2, dividing both sides by natural log of 2. I'm going to get x equals natural log of 7 over 5 divided by natural log of 2. Ooh, and running out of space quickly. Okay, let's plug that into our calculator. All right, so pulling this one up. We're going to do the natural log. Let's see, I'm going to move my screen out. Can't do that. Okay, raising camera. All right. Natural log of 7 divided by 5. 7 divided by 5 divided by natural log of 2. What do we get? 0.4854. All right, so let's go ahead with 0.485. Okay, so the reason that I chose to do natural log, or you could have done common log, is because it's easier to just use these keys instead of having to go in and pick your base and everything. Because most calculators will have natural log and common log on your calculator and no other options for the base. All right. Ooh, fancier. Okay, let's see. Well, my variable is in the exponent, so I know I'm looking at an exponential equation. Let's see, what options do I have? I can't match these bases. That's a 5 and a 3. So since I can't match them, my only option is I'm going to take the natural log of both sides. Or you could do the common log. All right, so writing this down. So the reason I'm taking the log of both sides, you might be saying, oh gosh, that's making the equation just look so much more complicated. The reason is I have that lovely rule that I can bring. Once I take the natural log, I can bring the exponent out in front. So a way I like to remember it is to get the apple out of the tree, you could just log the tree down. In reality, most people don't do that. You just pick the apple. But you log to get the apple out of the tree. Sometimes it works. All right. So then we have x minus 2 times the natural log of 5 equals x plus 1 times the natural log of 3. All right. So we have this binomial being multiplied to my natural log, also happening on this side, and I'm trying to solve for x. So my plan is I want to get x on one side. But to do that, I need to get x out of these parentheses first, which means I will distribute my natural log in to the binomial. Okay, notice this is a binomial on the outside. This is not a binomial in the argument of my log. So that would be x ln 5 minus 2 ln 5 equals x ln 3 plus ln 3. And as mentioned before, the reason I use a scripted ln is because sometimes if I don't do that, it'll end up looking like a 1. And I want to avoid my own confusion, so I tend to use a scripted ln. All right, let's see, where is x? X is da und da. Okay, so we're going to get those terms on this side and the terms that don't have x on the other side. So subtracting. And let's add these terms. right, what do we have? We have x ln 5 minus x ln 3 equals ln 3 plus 2 ln 5. We can't combine any of these because the ln terms are all different. So how do I get x to appear one time on this side? Well, x is a common factor, so I can pull that factor out. So factoring out x, ooh, we're getting close to the finish line here. All right. Well, it's just x multiplied to this binomial, so to get rid of that binomial, we'll just divide both sides by the binomial. Okay. So dividing both sides by ln 5, ln 3. I'm left with x equals ln 3 plus 2 ln 5 all over ln 5 minus ln 3. Which, remember, we need to state the solution, so I'm going to go ahead and plug that into my calculator. All right, here we go. Okay, so because we've got a bunch of binomials going on, I am going to be using a good amount of parentheses. So I want my top term, the term in the numerator, in its own set of parentheses. Let me pull the camera out again. All right, so in its own set of parentheses, let's do open parenthesis, natural log of 3, close that parenthesis, plus 2 natural log of 5, close that parenthesis. And then I'm going to close, Then I'm going to close my numerator in the parenthesis. Now I'll divide, and I want to put my denominator in its own set of parentheses, so I'll open the parenthesis. Then we're going to take natural log of 5, close the mini parenthesis, minus the natural log of 3, close the mini parenthesis. And we're going to remember we're closing in our entire denominator in parentheses, so I'll close that final parenthesis and hit enter. Aha! And there we go, our answer, 8.45 something something. So rounding that off, that's going to be x is approximately 8.45 and round up to 2. All right, not bad, not bad. Okay. E. Ooh, and E has a lot of E's in it. Funny. Okay. Bringing my camera down. Okay, let's see. Options here, options here. Well, I could set both sides equal to 0. But then when I do that, I'd have a problem because... Here, I'll show you what my problem would be that I'd run into. Okay, I could set one side equal to the other side and try to take the natural log of both sides. So I could do 2x e to the x equals negative x squared e to the x. But doing that, I want to use that exponential property when I take the natural log of both sides. And then negative worries me there too. Oops, e to the x. So I'd want to use that. Oh, and here's, of course, white out on a blue sticky note. Doesn't work very well, does it? Okay. So if I tried to take the natural log of both sides, I'd want to use that rule to bring the exponent out. But I'm stuck here with a problem, because that exponent is only applied to the e. So I can't use that rule to bring it out in the front, because that x is not being applied to the 2 or this x. Plus, when I do that, I still have an x in the argument. Okay, that's a problem. I'd have an x out front and an x in the argument, so that's not really working. So I'm going to think of another plan. Notice my x appears in multiple places. It's also down on the main bottom line, and it's in the exponent. So I'm going to kind of treat this as a normal, like quadratic, because notice we have x squared. Okay, and if we have a normal quadratic, you factor, right? So let's go ahead and do that. Let's factor out the common factor, which is e to the x times x. And what's left? Well, 2 plus x equal to 0. And what do you know? We factored this, and now we can go ahead and set each factor to 0, zero factor property. So e to the x equal to 0, x equal to 0, and 2 plus x equal to 0. So solving each of these, well, that's already solved. e to the x equal to 0. Can I raise e to any power and get 0? Nope, never going to happen. So we have two answers, x equal to 0 and x equal to negative 2. Okay, so the reason I had to change my tactic up on this one is because my variable was also down on the normal, what I just call it the baseline. That's not really the word for it. But my variable was on the normal solving line, and it was up in the exponent. Okay, that's where I had to change my tactic. Because notice on the other ones, my variable was always just in the exponent. So the tactic there was more similar for all of these. Okay, so you have to watch where your variable is. That tells you which strategy you need to solve. All right, let's see. Example 2, solve by graphing. Okay, so we're going to pull out our calculator. Solving by graphing. Let me adjust my camera again. All right. So for solving by graphing, first what I want to do is I want to estimate kind of where 2 to the x is. So, actually let me move my calculator over to here. So 2 to the x equals 7. Well, I know that 2 to the second power equals 4, right? And then 2 to the third power equals 8. So I know that 2 to the 7th, or 2 to the x equals 7. That's got to be somewhere in between here. 2 to the x is somewhere in between 2 to the third power and 2 to the second power. All right, so what I'm going to do, I'm going to go ahead and check this with my calculator. So we're going to go to y equals. So first, y equals. So whack that button. Okay, you can kind of see it on my calculator. All right, and then we're going to type in our equation, which is 2 to the x power. Oops. Delete. 2 to the x power. And I put a video of this on your Laulima under video help if you need another review on how to do this. So the 2 to the x power equals 7. Okay. Actually, sorry, we're just putting in 2 to the x, not equals 7. Just put in y equals 2 to the x. All right, and then second, we're going to go to second window. So second window. All right, once we're there, third thing we're going to do is the table start. We're going to start that at the value of 2 because we know it's in between 2 and 3. So we're going to start at 2. Okay. And then the change in table values. Change in table. We know it's not going to be by ones because 2 to the second power is 4. And then if I do 2 to the third power, boom, I'm past 7 already. So we're not going to start in ones. Let's just go with decimal points of 0.1. Okay. I wouldn't count by ones because if I did that, I would totally skip my answer of 7. All right, so we're going to do that. And then we're going to do step 5, table graph. So second graph. All right, and now we got my little table here. So I'm going to be searching for the y value of 7. And once I've done that, I'll look for the corresponding x value. So let's go ahead and search for a y value of 7. Ooh. Okay, so I have the y value of 6.96 and the y value of 7.46. So the one that is closest to 7 is actually this value, 6.9644. So the corresponding x value for that is 2.8. So my x value is approximately 2.8. Okay, and that'll give me roughly the answer of, that's almost 7. This one's closer to 7 than this, okay? All right, so that's how we would find that, by graphing and using your graphing calculator. All right. Readjusting the camera. So here we are with logarithmic equations. Okay, so a large important reminder. Okay, when we're solving logarithmic equations, you need to check your solution. Why? Remember, with logarithms, your arguments can never be negative. Just like in life, you should always have positive arguments with other people. There should be a reason for why you're arguing, to have a solution. Okay, so arguments should never be negative. So we need to make sure when we get an answer, for example, if I got answer of x equals -6, and if I plug that into here, that would make my argument -4, which I cannot have. So that x equal -6 would be extraneous. But you have to be careful, because sometimes x can be a negative number. If I had x equal -1 and I plugged that in to my argument, I'd actually just get log 1, which is okay. We just have to make sure it doesn't make my argument negative, okay? So how come we didn't have to check for exponents? Well, there is no restriction on raising a number to an exponent. Okay, exponents don't have a restriction. Logarithms do. Okay, the argument cannot be negative. So let's see, when we're solving this one, plan here. Well, plan, I want to get to the x value inside my argument. Okay, at the moment it's stuck in an argument. So my plan is to change to exponential. So change to exponential form. Okay, so doing that, my base is 10. So 10 to the first power equals x plus 2. Okay, solving for that. Minusing from both sides. Oop, there went my highlighter. 8 equals x. Okay, so before I box my answer and run away happily, I need to check. When I plug the value of 8 into my logarithm, is it still positive? Well, 8 plus 2 is 10. So, yeah, we're all good. Okay, now you may run away happily. Okay, well, not yet. We still have these to finish. All right, next. Okay, notice. This one, we had our log equal to a number. This one, we have our log equal to another log. So our tactic will change. This time, we're going to use that option of if the logs are equal to each other, if the logs are equal and the bases are the same, we can equate the arguments. So let's just check. Are both the logs exactly the same? Yep, ln and ln. All right, now we can equate the arguments. And solve. Okay, so then we have 2x equals 8, dividing both sides by 2. X equals 4. So before we go ahead and box this, let's check. 4 minus 2, that's still a positive. 6 minus 4, still a positive. So we're good. All right, nums C. All right, ooh. Okay, now this one's different. The previous one, these are our two main tactics, by the way, for logarithms. One way, you change to exponential. Second way, equate the arguments. So equate arguments. These are basically the two main tactics you'll use for solving logarithms. If you can't do this form, try for this form. If you can't do this form, try for this form. Okay, so at the moment, this